Hello, guys. Welcome back to Maths Zone African Motives. We are still on our mathematics and form. Actually, this was supposed to be the first video actually for Maths Zone African Motives. But if you check, there is a video that I did which was just covering everything about determinants. All right, but due to our members, they have asked that we must have this topic done as an introduction separately. So I think that can also be helpful so that you follow up the way that is supposed to be according to your syllabus. You follow the videos from the first one up to the end. They are going to be placed in a playlist in order. All right, so you just follow the videos like that. So without wasting your time, like I said, we are going to separate that. So this introduction is on our determinants, and I'm not going to go further or much on this introduction. I'm just gonna refer the basics up to finding of determinants. All right, and we proceed like that in a playlist, so that is gonna be helpful. All right, so as we consider determinants, determinants were actually being taken from matrices. We have matrices, only that we are not going to focus on simplification or evaluation of matrices, which is simply a presentation which can be a square or a rectangular presentation where we are referring to the same elements. Let's say we can present 2, 3, 4, 5 like this. This presentation is a matrix presentation. So we have got the matrix 2, 3, 4, 5, which has got rows and columns. So a matrix has rows and columns. You refer it in terms of how many rows and how many columns do we have. So the order of a matrix, we are referring first order, is determined or obtained from the number of rows versus the number of what? Columns. So it's how many rows do we have? How many columns? So I'm not gonna refer much on our matrices, right? Let's say I've got something like this, 1, 2, 3. When you refer to a row, this horizontal lines, these are rows. And we have columns in this manner. These are our columns. So if we are to consider this matrix that we have here, how many rows do we have? We must count the rows. Like this one here is in a row. So we've got 1, 2, 3. 1 is in a row, 2 is in a row, 3 is in a row. In its row, separate rows. 1, 2, 3. So we are going to state the order of this given matrix according to the rows versus what? Versus the columns, like I said. So it's how many rows? 3. How many columns? As we can see, we just have a single column, this one, which consists of all these numbers. It's just a single column that we have. So this is referred as a 3 by 1 matrix, or a 3 by 1 column matrix, since it's just a single column that you have. So you can actually specify 3 by 1 column matrix, or just a 3 by 1 matrix. So if we are to present these matrices, they can be added, subtracted, depending, but we are not to dwell into that. All right. So this is about the order. If you take this one, We have got 1, 2 rows. 1, 2. Remember, rows first. So it's a 2 by how many columns? 1, 2. So that's a 2 by 2 matrix. So you can also call it a 2 by 2 square matrix. So that is the presentation actually that you have on what? On your matrices. And these are the ones that brings in determinants. You are going to calculate, or you're going to determine the determinant. It was taken from a matrix. The determinant was taken from a matrix. So we have got the determinant notation, how to present a determinant. So if I'm to have the determinant from a matrix, we can present it in form of a square matrix like this. All right. Or we can simply use these lines that are vertical lines in that manner. And this is the major presentation that we are going to use. But we can use this or we can use that. So we see the difference. The matrix we're just presenting like this. We put the numbers there. So the moment you see these lines now, these lines like this, you know that it is to determine the determinant of a given matrix. So if I'm given something like this, the question is determine. We've got 3, 1, 4, 5 like this. Then you're asked to evaluate or to determine. They're simply saying calculate the determinant. These lines, determinant of this. So we are going back to that order that we referred before. In order for you to determine the determinant, we have, or we need the order. The matrices that we are going to focus on, where we determine the determinant, is on a 2 by 2 matrix. So we're going to find, in our case, it will be the second order determinant. Second order is simply from a 2 by 2 matrix. So us will be referring it as the second order of what? Of finding determinants. Second order. If we have a 3 by 3, that one will be the third order. Third order. So you're going to find determinants under what? Under the second and under the third order. This is the case. Simply from a 2 by 2 matrix, simply from a 3 by 3 matrix, 3 rows, 3 columns, 2 rows, 2 columns. So that is what you're going to look into. But in this specific class, we are going to just focus on the second order. All right, on the second order. So that is the major case that you're going to have when you have to determine the determinant. So someone is going to ask, all right, how do I present that determinant? Like, how can I write in short? Yes, this is the presentation that you are to determine the determinant's notation. So you can simply write in short determinant in short. Or you can present with the letter D, or you can use the delta. All right, so D or delta, or you can just write determinant. So if I want to find the determinant of a certain matrix, I can just write determinant is equal to I calculate it. Or I write D is equal to I calculate it. Or delta is equal to I calculate. These are presentations that we can use in short to represent what? The determinant. All right, so like I said, we are going to focus on the second order for this class. All right, so let me just have this one, the second order determinants. So the question is, how do we determine the determinants of a 2 by 2 matrix That is the question. How can we determine determinant of a 2 by 2 matrix or the matrix of order 2 by 2? This presentation is here showing us 2 rows and also 2 columns. This is the presentation of a second order. So that is the structure that we can have. So in short, we can use letters A, B, C, D. The determinant of A, B, C, D. 2 rows and 2 columns. So to determine the determinant, you simply multiply, in this case, these terms or numbers that you're going to be given in the major diagonal or the principal diagonal. Right? Let me just write this one. As for me, I use the word major. So it is the major diagonal, or you can just have this one as the principal diagonal. Principal diagonal. And we have the minor diagonal, which we can present it as the secondary diagonal. So as for me, I'm just going to take it as the minor diagonal. You can present this as our secondary diagonal. All right? So these multiplied together, these are multiplied together. So in simpler terms, when we are given this presentation, the determinant of A, B, C, D, a 2 by 2 matrix, is given as the product of what is in the major diagonal, so the product of the major diagonal A and D, minus the product of what is in the minor diagonal, which is our secondary diagonal BC. So this is the case. You multiply A to D minus B to C. From there, you have your determinant. You're done. Simple like that. So mathematics, as we know, it's a follow-up procedure. Once you follow up this, you're done. So questions can be determine, evaluate, all right? So if I'm given something like this for an example, evaluate, all right? Then we are given something like this. 7, 2, 8, 3. Evaluate. What is it that I'm supposed to evaluate? That is the question. There's nothing that I'm given. I'm just given this. These lines, remember, once you see this, determinant here, determinant. So the question is simply determine the determinant of the matrix that you're given here. So the determinant, which I can write as delta, I can use determinant is equal to, like I said, it is in your hands. So delta is equal to what? The product of the major diagonal A times D. So if you want, you can write A, B, C, D. This one is in your hands so that you can properly see this is A and D. I'm going to multiply these two. 7 times what? 7 times 3 minus the product of the minor diagonal, which is our secondary diagonal, 2 and what? 2 and 8. So I have to multiply these together, 2 times 8, just like that. So this will be our determinant. So just like that, 7 times 3, that is 21, minus 2 times 8, 16. Subtract this, you're going to obtain what? A 5. You can use your calculator. It is in your hands. All right, let us consider another question still on evaluating. All right, let us say we're given something like this. Questions, guys, are just direct. Do not even worry about this. Just do revision, more questions, right? So we are given minus 3 over 5 and 2, and also 1 over 6 here, 5 over 12. The question is to evaluate. Like I said, it simply says determine the determinant. So what is the determinant? Product of what you have, A and D. A times D, the major diagonal. So that's negative 3 over 5 times 5 over 12. That's our major diagonal. Minus what we have in the minor diagonal, the secondary diagonal, 2 and what? 2 and 1 over 6. So that's 2 times 1 over 6. Just like that. So we can evaluate this. It is you and your calculator. You can use your calculator. This was going to give us negative 1 over 4 minus 1 over 3. All right, then evaluate, you're going to obtain negative 7 over 12. Just like that. So do more questions on determining the determinant from the second order. So sometimes you'll be given the determinant of a certain matrix, then asked to solve for x, for the unknown value that you're given. Is it x? It can be m, whatever that you're given. For an example, the determinant of 2x 3 minus 4 5 is equal to 7. The determinant of this is equal to 7. Already you are given the answer. And the answer must be 7. So what are we going to do to solve for x? It's an equation once it's like this. So we must form an equation where we can solve for x. It's from an equation. So that equation is determined from where? The concept here is determinant. So you refer back to the determinant. How you calculate your determinant? AD, the major diagonal. A and D, our principal. So if I multiply 2x and 5, all right, then subtract the minor diagonal B times C, which is 3 and what? Minus 4. If I subtract the product of these two, 3 times negative 4, I'm supposed to obtain positive 7. I'm already given the answer to say this is our determinant. So as we calculated the determinant, and we have got our answer, which is what? Which is 7. Let us solve for x because we have formed an equation. Left-hand side is equal to what? Right-hand side. So 2x times 5 is going to give us what? 10x. All right, there's a negative. If I multiply 3 and negative 4, that's negative what? 12. Okay, and that's equal to 7. So as we can see, negative and negative here is going to give us a positive. So these two here give us a positive. So it's going to be 10x plus 12. All right, which is equal to what? Which is equal to 7. So this is a linear equation. The highest power is 1 on x. So you can simply take the 12 to the other side or subtract the 12, both sides of our equation. So that's 10x. This will cancel. 7 minus 12, that's negative what? 5. So to find x, simply divide by 10 by 10. You're done. We have a product, so you have to divide to obtain the value of x, which is going to be negative 1 over 2 or negative 0.5. You can have it as a decimal or you can leave it as a fraction like this. So questions can be like that, where you are given the determinant in terms of a certain unknown value and you are asked to solve for that unknown letter that you'll be having. So sometimes it can form a quadratic equation. Here we had a linear equation. You solve according to the equation that you formed. It can be an exponential equation. Solve those exponents. You refer back your exponents. It can be a logarithmic equation that is being formed. Solve, because you have done your logarithms. So you refer to the equation that is being formed. All right, let's consider this one. The determinant of 2x, 3, 4x is equal to negative 5x. Solve for what? For x. So still determinant. So we go back to the format. What is it that we have in the major diagonal? Multiply those two. 2x times x. All right. We're going to multiply this minus what we have in the minor diagonal, 3 and 4. 3 times 4. This is supposed to give us what? Negative 5x. All right, let's multiply. 2x times x. This is going to give us 2x squared. Minus 3 times 4, which is what? Which is 12. This is equal to negative 5x. Like I said, you are going to form an equation. You solve according to that equation. This is a quadratic equation. The highest power is 2. So we have a quadratic equation here. And we know the format must be in this format. Ax squared plus bx plus c is equal to 0. This is the format always of a quadratic. One side must be equal to 0. So meaning to say, in order for us to have one side equal to 0, we can transpose this one to the left-hand side. As it is a single term, let us take it to the left-hand side. So we're going to have 2x squared representing ax squared minus 5x to the other side will be positive 5x. The moment it crosses the equal sign, it changes the sign. Minus 12. And that's equal to 0. So to solve here, I'm not gonna explain much because it is you and your simplification is you have got your quadratic equations. You can solve them by factorization. You can solve them by the use of the quadratic formula. You can solve them by completing of the square method. It is in your hands. It is in your hands, that one. All right. So if you're going to use factorization method, also I'm not gonna dwell into that factorization methods, guys, because there are so many ways that we can use to factorize. So what you can do is to watch videos, maybe grade 10 videos that I've done on factorization, grade 11. Check those methods because there are so many methods, all right? Or just simply use quadratic formula. But if you were to factorize, you're going to have two brackets of x plus 4 into 2x minus 3. So I just want you to factorize properly. If you're using factorization method, if you're using quadratic formula, then just use the formula direct. X is equal to minus b plus or minus the square root of what? B squared minus 4ac over 2a. So therefore x is equal to minus, this is a, this is b, this is c. So minus 5 plus or minus the square root of b squared, 5 squared minus 4 times a, which is 2 times c, negative 12. Everything over 2 times a, that's 2 times 2. All right, so just use the formula if you are comfortable with that. All right, so from here, if you're going to solve x minus 4, plus 4 is going to change to a negative. Or x is going to be negative 3 to the other side is going to be a positive 3. Then you're going to divide by what? By 2, because it will be 2x is equal to 3. So you're going to need to divide by what? By 2. So these are the values of x that you're going to have at the end. So if you're going to use the quadratic formula, still you're going to obtain same values or the same answers like what we have here. So that one, it is in your hands how to solve quadratic equations. All right. So many ways that can be applied or used. So please just do revise that one as a separate topic if you do not understand. On number 3, Let us consider this. Like I said, it can be an exponential that you are given. Solve those exponents, right? So refer back exponential equations, basics of those. All right. So in our case, this is what we had. Determinant of this is equal to what? 5. So like I said, the product of what is in the major diagonal first. 2 to the exponent of x times 2 to the exponent of x minus the product of what is in the minor diagonal. 1 and 3 or 3 and 1 must be equal to what? 5. Already you're given the determinant. So it depends with the arrangement of what is inside. Sometimes you're going to form an equation like this. It depends with what is inside. Just work out according to the question that you're given. So according to what we have here, there we are multiplying numbers of the same basis from our laws of exponents. We are going to add our exponents x and x, which is going to give us what? 2x. Laws of exponents, x to the exponent of a times x to the exponent of b. You add the powers. So you add x plus x, and that is what? 2x. Minus 3 times 1, that is 3, and that is equal to 5. Are we seeing that minus 3 and 5, these are constants? So we can evaluate these two. We can take 1 to the other side of the equation. So you can simply take minus 3 to the other side of the equation, or just add 3 to get rid of that 3 on the what? On the left-hand side. So this can cancel. So 2 to the exponent of 2x is equal to 5 plus 3, which is 8. Remember from your laws of exponents that if the bases are the same, x and x, if the bases are the same, automatically the exponents will be equal. A will be equal to B. So can we have this condition that the bases are the same? Yes. 2 is in the simplest form. All right. 2 is a prime number. So it is already in simplest form. So do not focus on that one. Focus on 8. 8 is not a prime number. So how can we have it in exponential form? 8 is equal to, then shift, you press fact. Shift, you press these dots here. That's the fact. So, all right, did I press the shift? Sorry for that. 8 is equal to shift. You must see this S. All right, so like this. So you press shift, then fact. So it's going to give us 2 to the exponent of what? Of 3 in simplest form. So this is 2 to the exponent of 3. The bases are the same, just like x and x. So automatically, 2x is equal to what? It is equal to 3. Back to a linear equation. To find x, simply divide by what? By 2. Since we have a product. So x is equal to 3 over 2. That is the case. It depends. These are exponents. You're dealing with exponential equations. You can revise. I think your N3, we used to have this, and N2, your exponents, and also logarithms. All right, let us just end with the one that has got a log. All right, 3, 5, -2, -4 is equal to the log of x. We have a log. All right, so determinant of this is equal to the log of x. So let's determine that determinant from our formula, AD minus BC. The major diagonal, 3 and what? -4. Minus the minor diagonal, which is 5 and -2. So if I multiply this, if I combine this, I'm obtaining the determinant of the matrix. And we are told that, we are given that it is equal to what? The logarithm of x. It is equal to log x. We have an equation that we need to solve. So if we are to evaluate the left-hand side, these are just constants. So multiply those, simplify. 3 times -4, that's -12, minus 5 times -2 is -10. And this is equal to the logarithm of x. All right, negative is going to give us a positive. So -12 plus 10, that's what? -2. So we have -2 equal to the logarithm of x. All right, whatever presentation, whether the log is on the right-hand side or it's on the left-hand side, you can solve for x. But most of you are used to, if we have the log on the left-hand side, so I can rearrange, just here is just rearranging. A is equal to B simply means B is equal to what? A. We are not going to change any sign. So log x, we can start with the log x and is equal to what? -2. As it is, nothing has changed. Just rearranging. So how can I solve for x? Remember, if a base is not given, every logarithm has got a base. If you check on your calculator, there is this log here. Log, if you press that, it gives you a base. Log like this. It gives you a base. So it's log of a certain number, let's say logarithm of 8, but it is in the base of 2. So if the base is not given, like what we have here, we do not have here, the base is not given, it means you're in the base of 10. 10, we can choose not to write the base of 10. So this simply means we are in the base of 10. Why is it important that you must know about the base? Because a logarithm can be converted to an exponential from log A, B, C. Log A in base of B equal to C. This can be written in exponential form. This is a log form. Exponential form, A is equal to B to the exponent of C. So these are two formats, different formats, exponential, logarithmic. So one can be converted to another. We can even convert from exponential back to logarithmic. We simply write it this way. So A is equal to B to the exponent of the base to the exponent of the answer. So what represents our A? Log of x in base 10. Our A is x. So therefore, from this log, we can convert it to an exponential. So it will be x representing our A. So x is equal to B to the exponent of C, the base, raised to the exponent of the power, 10 to the exponent of -2. Which is easier for us because it gives us direct x, the value of x. We no longer have a log there. Like we no longer have it's not log A, no. It's A. No log. Here, there is a log. Here, we do not have a log. So there is no log that you write here. All right? So if x is equal to 10 to the exponent of -2, that's 1 over what? 1 over 100. All right? You can just use your calculator. 10 to the exponent of -2, that is 1 over what? 100. Or you can have it as a decimal. It is in your hands. So you see, it'll be good that you go through the basics, as we saw from these determinants, that sometimes you can form just a basic linear equation. You can form a quadratic from that. You can have a quadratic equation. Sometimes it is an exponential equation. Sometimes it is even a logarithmic equation that you're given there. So it does not end there. You can also have, as long as an equation, remember we also have trigonometric equations. Once you're given a trig, a tan of this or cos of this, we are back to a trigonometric equation. So any type. And even sometimes they can give us questions under the application of our complex numbers. Complex can be a complex equation from our complex numbers, depending what we are given there. So you must revise all these basics. Solving each type of equation that I presented there, so that when it is involved in these determinants, you know that, okay, I have a logarithmic, I have an exponential, I have a trigonometric, I have a linear equation. You solve according to the equation that you have formed. So these are the typical questions that you might have. Let us do revise. We shall meet again in the second class, where we shall be focusing on determinants again, but this time it will be on the third order now. The third order. This was the second order. So we are going to have the third order. So that is it till we meet again.